the first time with sine and cosine, we solved for both the side and the hypotenuse. So we used both of them. And tangent, it was pretty much we were solving for one of the missing sides. It was one or the other. And what we're going to do today is going back over that one more time just to kind of make it clear of what we're doing and how we're doing this here. Let's close the Chromebooks. So when we look at any of these here with sine, cosine, and tangent, well, sine is opposite over the cosine is and tangent is opposite over adjacent. Now, one of the ways that you can learn these or kind of memorize these is so, ka, toa. So, ka, toa. What do y'all think that stands for? Sine is opposite over hypotenuse. Toa, let's see here, C-A-H, and toa. So, ka, toa. Well, C-A-H stands for what? Cosine is adjacent over, and toa is, tangent is opposite over adjacent. So kind of one of the ways to memorize this is so, ka, toa. So, ka, toa. Sine is opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. And toa is opposite over adjacent. And this is just kind of a way to memorize these and see what they are. Now, when we look at solving, because when we looked at it the first time, with sine and cosine, it was pretty much we were solving for both missing sides, the hypotenuse and one of the missing sides, so we did both. Or we were solving for two missing side lengths, so we used both. Now, the homework didn't give us both. It just told us we were solving for one of the sides of the hypotenuse. It only gave us one, right? And that's what's key is that, well, we could use sine and cosine, but one of us will actually help us solve for the missing side length, and one of them will solve for the one we don't need. So when we approach these here, when we approach all of these problems, we need to be thinking, what am I trying to find and what am I given? Because those are going to be the two key questions. Now, when I look at this here, well, I'm given the angle 26 degrees. And what else am I given? The hypotenuse, yes? So when I look at the three trigonometric figures, or trigonometric equations we have with sine, cosine, and tangent, which one of these three uses hypotenuse? Sine and cosine. So I'm either going to use sine or I'm going to use cosine. Now, what am I solving for? So I'm solving for y, yes? So how does angle y and our angle here relate to each other? They're adjacent. So which one of them, sine and cosine, uses adjacent? Cosine. So that means I'm not going to be using sine. So we're going to use cosine of 26 degrees. So when we look at these here, we're looking closely at what am I trying to solve for and what am I given. Since I'm given the hypotenuse and I'm solving for the adjacent side of that angle, we're using cosine. So cosine of 26 degrees is going to be y over 14, adjacent over the hypotenuse. Now at this point here, what do we need to do to solve for the missing side length? Multiply both sides by 14. And when we do this here, we'll get y is equal to 14 cosine of 26, which tells me y is equal to 12.6. And that's it here. So really when we're looking at these here, we need to be able to figure out what we're solving for and what we are given. and looking at how they relate to each other, because that's going to tell us which of the three trigonometric functions we're going to use. Because if we use sine of 26 and set it as y equals 14, it wouldn't be giving us the correct answer, because it would actually have given us this side length over here. Now, also looking at this here, well, we know some of the answers, whatever y is, shouldn't be bigger than 14, yes? And it should give us some perspective of how the numbers look. So let's look at the next one here. So this is a similar problem, yes? Well, it's the exact same problem, but what changed? The variable. We're solving for x, but how is 26 degrees and x relating to each other now? These are opposite, yes? Well, which one of our trigonometric function uses opposite? Sine and tangent. Both of them use opposite lengths, yes, from the angle? Right. And because we're given the hypotenuse, we're going to be using sine. Well, that's kind of interesting, isn't it? Because tangent's only what? Opposite over. So if I'm not given the hypotenuse and I'm not solving for the hypotenuse, it's automatically going to be what? Tangent. So here we're using sine of 26 degrees is equal to whatever what? X over 14. Well, right, we'll still multiply both sides by 14, which tells us x is equal to 14 sine of we agree with 6.1? Yes? And that's it. That's all we have to do for these here. Because we have opposite is what we're looking for, and we're given the hypotenuse, we're going to be using sine, because it has opposite and the hypotenuse for what we're plugging.
Pretty much the same thing, except it's different. You're switching up the sine.
Yes, because it's what we're given and what we're looking for. Since I was given the hypotenuse, and I was looking for the opposite side, okay, I'm going to be using sine. It's like what I'm plugging into. Now, because we're given the adjacent side and I'm not solving for it, I wouldn't use cosine because it requires adjacent over hypotenuse. If I'm not solving for it, we don't need it. Because when we looked at this first time, because we were wanting both, okay, we'll use both of these here because we're going to find both of them. But here we're only looking for one value, so we don't need both. We're going to find the most efficient one. Okay, so if we look at this here, so we're given the angle 35 degrees. Now what else are we given? Right, y and 35 degrees are adjacent because they're next to each other, yes? So adjacent, so most likely it's either going to be cosine or tangent because sine deals with opposite. What else are we given? Because it's written as 53 degrees and it's opposite the right angle. So which one of the three uses adjacent and hypotenuse? Would be cosine. So we'd have cosine of 35 degrees is equal to adjacent over the hypotenuse. And to solve for this here, we would multiply both sides by 53, which tells us y is equal to 53 cosine of 35. 43.4, yes. And that's it. That's all we have to do for this here. Questions on any of this here? Mm-hmm.
Oh, let me suspend. My bad.
You're good. Mm-hmm. Any questions on any of this here so far? This making sense? A little bit more sense? So it's really, when we look at these here for sine, cosine, and tangent, it's really focusing on what are we needing and what are we looking for. So what about this one here? So we're given the opposite side. And what else? So which one uses opposite and hypotenuse? Sine, yes? Well, we'd have sine of 35 is equal to, well, we already know what y is, yes? Because we found the other side length just a minute ago, which was 43.4, yes? What do we expect this side to be? Well, it's going to be smaller than 53, yes? Yes. Because this angle over here, if we figured it out, would be 5, 4, 55 degrees. So that side that we're going to get for x should be smaller than it. So if we look at the angles, we can kind of guess, have a guesstimation of what we think it should be. Now, we would multiply both sides by 53. And that would tell us that x is equal to 53 sine of 35. It's kind of how we expected, isn't it? Yep. Awesome. I'm going to skip one, and I'm going to look at this one here, because I did skip over, I think, 2, actually. Yes, with sine and cosine. Because I want to move on to this one here. Now, this one here, well, we're still trying to find what? So we're finding the hypotenuse this time. So that means, unluckily for tangent, it's still out. Because could we find the hypotenuse eventually using tangent? Well, yes. Because this is still a right triangle, yes? So a squared plus b squared equals c squared still works. And we could find it using tangent, not directly. Because I could use tangent to find the other side length, not the hypotenuse, and then I could plug it into the formula to find the hypotenuse. But that's too many steps. I mean, we could do it and make it work, but it wouldn't be the most efficient way of solving it. This would be cosine. Why? So we have the adjacent side, which would be 11, and the hypotenuse. So we have adjacent and hypotenuse, so we're going to use cosine. Now, what are we going to do first? Okay. And that gives us x cosine of 37 equals 11. It almost feels like when we set these up, we multiply by the denominator of that fraction, the bottom of the fraction every time, isn't it? Because, I mean, the first few that we did, we multiplied by the number on bottom, yes? Here, if there's a variable on bottom, well, we multiply both sides by the variable. Yeah? But here it's a little bit different because, well, now I have x cosine of 37 is the variable by itself. Well, no, we got to get it. Yep. Divide both sides by what? Cosine of 37. Yep. And then if we get the variable by itself, like we did on the first few, plug it in. Well, here the variable wasn't by itself. Divide so it is, and now plug it in. See if I can hit it. There we go. Now, should this number, when we solve for these here, this setup, well, the number we get, should it be bigger than the side lengths that were given? Why is that? It's the hypotenuse. We're solving for the hypotenuse, yes? So that number should always be bigger than any of our side lengths. So 13.77. Any questions on this here? We can round it up to 8. Any questions on this here? How about this one? Why would we pick sine? Yes. And? Because 10.8 is opposite, but the real defining reason we picked it is because it is, 10.8 is our opposite side, and what else? Because we're looking for what? The hypotenuse. Because we're given this side opposite the angle, and we're looking for the hypotenuse. Opposite and hypotenuse would be sine. Now here we're going to multiply both sides by x, which will tell us x sine of 57 is equal to 10.8. Yes, we would divide both sides by sine of 57. $19.8. Scroll just a little bit. Right, and then we do 10.8 divided by sine of 57, which would give us our 19.8. Okay, thank you. 12.87, which would be 12.9. So I'm guessing the other one was cosine? Okay. Any questions on any of this here? Are we good with this here? Yes? Okay. There's cosine. This would be cosine because we have adjacent and the hypotenuse, yes? Okay, what would this one here be? Tangent. Because what are we not looking for? We're not looking for the hypotenuse, and we're not given it. So we're automatically using tangent. It's kind of the easier ones to pick out, because if I'm not given the hypotenuse and I'm not looking for it, it's automatically going to be tangent. Opposite over adjacent. Opposite. Yes. And to get x by itself, we're going to multiply both sides by 13. And I get x is equal to 13 tangent of 32. One, two, or 8.1 if we're rounding to the nearest tenth. Any questions on this here? Yes. Let's look at the next one. So this one here would be what? Tangent? Yes. Because we're not looking for the hypotenuse and we're not given it. So we're going to use tangent of 50.1 equals x over. Does it matter that the degree measure is a decimal? No, we'll still do the same thing. So we're going to multiply both sides by, and have x is equal to 5 tangent of 50.1. Or it would be 6.0 if we rounded to the nearest tenth. $9.979. So if we're rounding to the nearest tenth, so the ninth place would be our tenth, yes? So we look at the 7. Since the 7's greater than 5, we would round the 9 up 1, yes? Well, the next number after 9 would be 10. So it would become, round 1 up, well, we can't go up really any higher than 9, so it resets, moving the 5 to a 6, and the 9 becomes a 0. Mm-hmm. Oh yeah, the hundredths place, if we did hundredths, it would be 5.98. Yes. If we're doing hundredths place, it'd be 5.98. If we're doing tenths, it goes to 6.0. Mm-hmm. Yeah, I see what you're saying. Any questions on any of this here so far? All right. Because I think I feel like y'all are getting a better handle on this than we had the first time, yes? And I think this is the last one we have, yes? Okay. So which trigonometric function are we going to use? Yes, because we're not given the hypotenuse is equal to what over what? Because we're not given the hypotenuse, we're using tangent, opposite over adjacent. Opposite side of the angle is 4. The adjacent side is x, because we're not given it. Now the first step would be to multiply both sides by x. Now the ones before this, we were trying to get x by itself. Here, we're really multiplying by x to get it out of the denominator. Because if we're going to solve for it, we need it out of the bottom of that fraction. So we'd multiply both sides by x to do that. Now that we have x out of the bottom of the fraction, we need to get it by itself. We want to divide both sides by tangent of 41. Which these two would cancel out. Which leaves us with x is equal to and that would give us our answer here. Any questions on this here? Let's do one more. I want to do one more. I know we ran out of pictures. So underneath the last one, you can just draw a triangle. It doesn't have to be as nice as that because I kind of cheated to get that one. Let's find x, 5. Let's set this as 10. It would be cosine, yes? Actually, let me reset that. I don't like 5. Let's try 1. Let's try 1. Let's see what happens when it's 1. I like this one. So it would be cosine of 1 degrees is equal to x over 10, yes? Multiply both sides by 10. X equals 10 cosine of 1. So if you plug I thought the hypotenuse was supposed to be the biggest side. Well, really, what is this? 9 point what? That's why I chose this one here. I find it interesting. Because if we round, we actually get it to be equal to the hypotenuse. And when we round, we're not actually getting the actual measure. We're getting a, what? Approximation. We're approximating what the actual value is. And 1 degree, even though it doesn't look like it there because that's not actually 1 degree, 1 degree is actually tiny. 1 degree is tiny, tiny, tiny. Yeah. I'll use this here. Because it might be hard to see. But if you see that first little white dash right above where my finger is, that's 5. So that's not even 1 degree. So 1 degree is minusculely tiny. So what we're saying is that the difference between this side length and the hypotenuse with 1 degree is going to be very, very small. Which means this side length, because that's what this is, this side over here, if we were to find it, and the way we could find it would be using 10 sine of 1 degree. And what would 10 sine of 1 degree be? That other side length's really tiny. The other side is massively big. So I just kind of wanted to show you that one.